Hey everybody, this is the second video for the Advanced Algebra Trig Pre-Calculus lesson on linear and quadratic functions. We're looking at graphing them. We are going to start off today with our first example. So number one. I'll do this. Example number one. A little review to keep us going. Put the following in graphing form and sketch a graph. And I'll show you how to check your answers too. All right. So here it is. Y equals, okay, negative 4x squared. Ooh, this is different. Plus 16x minus 17. All right. All right, guys. Here it is. So what we did is that we took the quadratic and the linear term and we kind of separated things, right? All right. The goal here is to get it, here's my post-it from the last video, into graphing form, right? That's what we want it to look like. We want the x by itself. So let's factor out a negative 4. So I'm going to have an x squared. Negative 4 times x squared is negative 4x squared. Now, negative 4 times negative 4x will give me plus 16. So this has to be negative since that is negative. Again, negative 4 times x squared is negative 4x squared. Negative 4 times negative 4x is plus 16. Minus 17 is going to hang out here. We are just focusing on this. All the other stuff we'll figure out later. We want it to be something times something, which is something squared. And that's what my y will be equal to. All right, guys. X squared is x times x. These two have to be the same. What are the only numbers I can use that would give me an outside and inside combination of negative 4x that are exactly the same? Yep, negative 2 and negative 2. All right. So here we go. X times x is x squared. We have a negative 2x and another negative 2x. That's negative 4x. And negative 2 times negative 2 is plus 4. All right. So here's the deal. We didn't add 4. We actually subtracted 16. Does that make sense? So we actually subtracted 16 here. So to balance, so let's keep track of that. To balance my equation, would I have to add 16? And we're going to check this anyway, so if we make a mistake, we can just find out our answer by checking it. This will be negative 4 in here. This was x minus 2 squared, and that's minus 1. So we would say that the vertex, we would move to the right 2, down 1, right? And if I sketch this, right 2, down 1 would be here. It's going to reflect down, and it's going to be stretched, so we're going to have something that's stretched a little bit, and it's flipped down. All right, so here's how I find out if I'm correct, you guys, okay? And I'll flip back and forth and make sure that I can see things because it's hard for me to see with everything here. So we started with a negative 4x squared plus 16x minus 17, right? Our goal is to see if that's the same as negative 4 times the quantity x minus 2 squared, cross my fingers, minus 1. And all you have to do, so those are my two, all you have to do is look at the table. So I'll do that. Yep, the tables are exactly the same. Since the tables are the exact same, that means the equations are exactly the same. All right, so I just put it in graphing form. I put it in the standard form. Should be exactly the same, which it is. I love it. All right, so that takes me through everything with completing the square. I'm going to look at one other thing with graphing form. All right, guys? But I do need this because that's graphing form. That was my first example. Second example of the day. Okay? Example 2. All right. Write the equation for the parabola. Containing 1, 3, 0.1, 3, and whose vertex is 5, negative 2. All right, 5, negative 2. All right, here we go. This is graphing form. I'm going to use graphing form because standard form is ax squared plus bx plus c. And I don't have an a, b, c, but vertex, that tells me the h and the k. So far I know because the vertex is 5, -2, I know that my equation is going to be y equals a. There's something with an x in here, it's squared. If you have to sketch this out, we would move it to the right 5 down 2. Right 5 down 2. Okay, and we will check our answers in our calculators. I'm really big on checking answers. All right, now I have 3 variables. So I went from having 5 variables to 3. I'm feeling good about it. Now, it's containing the point 1, 3. Now, 1, 3, isn't there an x and a y in there? So we're going to use the point 1, 3 to find a. X is 1, y is 3. So we're going to substitute 3 in here and 1 in there. Here we go. 3 equals a times 1 minus 5 squared minus 2. 3 equals 1 minus 5 is -4. So it's going to be a times -4 squared minus 2. All right, 3 equals -4 squared is 16. That's 16a minus 2. Add 2. We're going to get the a by itself because that's what we want. 5 equals 16a. Divide by 16. A is 5/16. So my equation looks like it's this thing here, guys, but now my a is 5/16. Y equals 5/16 times the quantity x minus 5 squared minus 2. And I would actually sketch this out. So if 5, -2 is here, let's say, and it contains 1, 3, that'd be here. Wouldn't your parabola have to look like that? Because the vertex is here and the point's above, so it has to point up. Feeling good about it because this means it's pointing up. Feeling good about that. All right, let's check these. I'm going to put the equation in here because there's only one. 5/16, so I'm going to put 5/16 in parentheses. And then x minus 5 squared. And then minus 2. All right, here we go. My goal is to have 5, -2 in there and 1, 3. Cross my fingers. 5, -2 and 1, 3. So 1, 3 is my first one. There it is. And 5, -2. There it is. Feeling good about it. So that checks. All right. So my last thing is vertical free fall, you guys. I actually think I did this with you, and that's why I don't think I have too much for you on this one. But we have looked at vertical free fall back in the piece sections. So vertical free fall is going to be when an object travels in the path of a parabola. So it's going to be used when an object rises and then it falls. All right. I think I compared it to like a ball being kicked. We just did the rabbit problem in Algebra 2 where a rabbit was jumping over a fence. Here's your formula. Okay, I'll just give it to you. S equals, you've had this before, -16t squared plus v sub 0 times t plus s sub 0. And then there's another formula I'll give you in just a minute. This s right here is the height of the object. T's, in both of these, t represents time, usually in seconds. V sub 0 is your initial velocity. And S sub 0 is your initial height. Okay. And I'm going to add this. V sub t is going to equal the opposite of G sub t, or G of t plus V sub 0. V sub 0, again, is your initial velocity. And I think I have a couple of these guys together. Your negative g, you guys, is always going to be negative. In this case, it's -8. I don't use this one that much, but this is how I know it's -8. The other one here, and I'm going to put this on a Post-it because I'm not going to use this one that much. Okay. S sub 0 can also equal -16t squared. I'm sorry, not negative. I got -16t squared. My bad. S sub t can equal -1/2 times g times t squared, okay, plus v sub 0 times t plus s sub 0. Okay, so here's the deal. If I take this and I actually look at it being the same thing, right, because these are essentially the same thing, your g value, what's half of something gives me -16, that'd be 32. Sorry, so this is actually going to be 32. Your g is going to be 32. I don't use that much. V sub 0 is your initial velocity. This is your velocity at a certain time. All right. So again, I don't know why they don't give me the g, but if s is going to be equal -16t squared plus v sub 0 times t plus s sub 0, everything is the same except this -16 is -1/2 times g. G would have to be 32 because 32 times -1/2 gives me -16. Generally, you guys just need this, or you will get some points like you did in the last question. All right. So that brings me to one of the questions I do is sometimes I'll grab the book and I will do some examples. This is 63 because Math Excel kind of gives you different kinds of problems. You might actually get this. It's like a luck of the draw. So here is the question. And I'll just read it and I'll give you guys the key information. So in this question I usually do, it's at the Bakersfield 4th of July fire or celebration, fireworks are shot from a remote control into the air from a pit that is 10 feet below the Earth's surface. Okay, find an equation that models the height of the aerial bomb t seconds and after it is shot upward with an initial velocity of 80 feet per second, and then graph the equation. Second one is going to be what's the maximum height and how many seconds will it take to reach that height. So this is going to be my example 3 for the day. Okay, so at the fireworks, I'm not even going to give it a name, but the fireworks for a certain town, a machine launches the fireworks from a point 10 feet below ground at an initial velocity of 80 feet per second. All right, and there's 2 questions we're going to answer. Actually, we'll answer 3 because I've come up with more. So at fireworks for a certain town, a machine, I cannot write them. Sorry, if I had an eraser, I would just erase it. A machine launches the fireworks from a point 10 feet below ground at an initial velocity of 80 feet per second. First one, A, find the equation that models this information. Okay, so we're going to find the equation. All right, that is on the top here. Right there. So my height. I'm okay with you guys using y because y is what we're going to use for in our calculators anyway. So let's go with y equals -16t squared plus v sub 0 of t. That's my initial velocity, so that's going to be plus 80t plus s sub 0. That's my initial height. Now my initial height is 10 feet below the ground. That's actually quite low. So this is going to be minus 10, you guys. That's my equation. And I'm actually going to change these t's to x's. I wouldn't be that picky, but I just want to put this in my calculator, and I think that's easier. So that's A. Find the equation. Okay, and I'm going to flip this up here so we still have all that stuff that we need. All right. Sorry. I got I want to make sure it's straight for you because some people do not like it when things are not straight. Here we go. All right, B. How high does the firework get? And how long does it take to get to that height? All right. So how high does it get? And how long? So here we go. Let's put that thing in here, right? So you guys can see that my equation was negative 16t or negative 16x squared, which makes sense because fireworks should go up and then down. Negative 16x squared plus 80x minus 10. Now, fireworks probably going to go pretty high, you guys. So let's see what the table says. This thing is going to go, oh, it looks like about 86 feet high. And it's going to be below ground in 6 seconds. So let's make our x's go from 0, because our time's going to be 0, maybe to 6 seconds. And the height got to be around 100. Let's see what that looks like. Ooh, I like it. That looks pretty good. So if I'm going to sketch this, which normally I'd want you guys to sketch things, it doesn't have to be perfect. There it is. My window here, you guys, went from 0 to 6 on my x's, and then negative 10 to 100 on my y's. All right. So the question is, how high does it get and how long? I need that point. That's my maximum point. So second trace, let's get a maximum. And if you want to see if you get the right answer, you can just kind of pause it and do it yourself and see if you get it. Move off to the right, and it says left bound, move it off to the right, and looks like it's a 2.590. So you should get something at 2.590. So the question is, how high does the firework get? Well, our y's are the height, and we said that it was 80 feet per second, so it has a maximum height of 90 feet, and it takes 2.5 seconds to get there. And my last question is, how long is the firework in the air? I almost said hair. It's air. When I have to find this point too here, you guys? All right. So on my graph, that would be a 0. So second trace, that's 0. And we go off to the left. There it is. Left is going to be above. And off to the right would be a below. Press enter. And it looks like it is at, oh, I like this one. It's at 4.87. And then that negative 1 e to the negative 11th, that just represents 0 because it's like negative 1 times 10 to the negative 11th. If you move it to the left 11, it's like close to 0. So this is 4.87. seconds. There it is. All right. So that is all the notes for section 2.1. It has examples in there. I'm going to make up more examples. We'll go through those in class. Particularly, we need to complete the square because I think that some of you guys could use some help with that, especially with having coefficients in front of the x squared. All right. Good luck.